Chapter 5, Section 2 is titled Using Intercepts. So the first two terms I want you to write down are x-intercept and y-intercept. And the x-intercept is the x-coordinate of the point where the graph intersects the x-axis. And the y-coordinate of that point is always going to be 0. Similarly, for the y-intercept, it's the y-coordinate of the point where the graph intersects the y-axis, and the x-coordinate of that point is also always 0. So let's look at a couple examples. Find the x and y-intercepts. Here the x-intercept, often it's abbreviated x-int. So we're looking at the x-axis. Here's the x-axis. Where does the line cross the x-axis? And here it crosses at -2. So the x-intercept we can write is -2. And if we want to write as an ordered pair, we can say -2, 0. Notice that when there's a point on the x-axis, it doesn't have a height. The height is 0. So that's why it's -2, 0. For the y-intercept, very similar here, but now we're looking at the y-axis. So where does the line cross the y-axis? And it crosses up at +3. And the ordered pair here is 0, 3. Notice if we start at the origin and we try to label that point, we aren't going left and right at all, so that's why the x value is 0, and then up 3. Another example, find the x and y-intercepts. So the x-intercept and the y-intercept. And here again we'll label it as just the number, and then we'll label it as an ordered pair. So the x-intercept, again, we're looking at the x-axis. Remember, that's the horizontal axis. It's at +7. And if we labeled it as an ordered pair, it would be 7, 0. For the y-intercept, we're looking at the vertical axis. The line crosses down at -3. And we would label this point 0, -3. So let's determine how we can find the intercepts given an equation. So to find the x-intercept given an equation, we want to put 0 in for y and then solve for x. So let's go back and look at that last example. We're putting 0 in for y because the 0 is, or the y value at that ordered pair is 0. Then similarly, to find the y-intercept given an equation, we're going to put 0 in for x. And if we go back, we look at the ordered pair, notice that the x-coordinate of the y-intercept is 0. That's why we put 0 in for x. So kind of remember opposites. For the x-intercept, you're putting 0 in for y. And for the y-intercept, we're putting 0 in for x. So let's find the x and y-intercepts of the solution, and then let's graph the line. It's very easy to graph lines using intercepts. So first we're going to find the x-intercept. And some of you will be able to do this pretty quickly, but I'm going to show the full work, at least on the first couple of examples. So to find the x-intercept, I want to put a 0 in for y. So we're going to have 4x minus 3 times 0 equals 12. And you'll see quickly what happens here. 3 times 0 is 0. This term goes away. So we have 4x equals 12. Divide both sides by 4, and we get that x equals 3. So the x-intercept is +3. Same thing for the y-intercept, except now we're plugging x in for 0. So it's 4 times 0 minus 3y equals 12. Again, this term is going to cancel. 4 times 0 is 0, so it goes away. We have -3y equals 12. Divide both sides by -3, and we get that y equals -4. So we have an x-intercept of 3 and a y-intercept of -4. So when we graph this line, we're going to go to +3 on the x-axis. We are going to go to -4 on the y-axis. And we're going to connect the dots to draw the line. Very easy to graph. Notice I don't have to make a table of values here. In order to draw a line, you need at least 2 points. So as long as we have 2 points, we're able to draw our line. And we do. Our 2 points are the x-intercept and the y-intercept. Let's look at another example. To find the x-intercept, again, I want to put 0 in for y. So we have 2x plus 3 times 0 equals 12. And this term is going to go away, becomes 0. So we have 2x equals 12. Divide both sides by 2, and we get an x-intercept of 6. Same thing for y-intercept, but now we're plugging 0 in for x. So 2 times 0 plus 3y equals 12. And again, this term becomes 0. So we have 3y equals 12. Divide both sides by 3, and we get that y equals 4. So we have our intercepts, x-intercept of 6, and a y-intercept of positive 4. And now we can connect our dots and draw our line. We want to make sure we extend our line almost through the entire graph. Remember also these are lines, so they should have arrows on both ends. Go ahead and try this one on your own. See if you can find the proper intercepts and graph it correctly. So pause the video here. To find the x-intercept, and I'm not going to do quite as much work this time, I know that this y term is going to go away because I'm going to plug a 0 in. So I just have 2x equals 4. Divide both sides by 2, and we get x equals 2. For the y-intercept, similar, the x term is what I'm plugging the 0 in for x, so that goes away. We have negative y equals 4. Please make sure you understand that that minus sign goes with the y. So then I need to divide by a negative 1 and get y equals negative 4. So now when we go to graph an x-intercept of positive 2 and a y-intercept of negative 4, and we want to connect our dots to draw the line. Hopefully you got that one right. If not, you can see where you made your mistake. Another example, x-intercept and y-intercept. And again, some of you are going to be able to do this with even less work, maybe not even writing the equation at all. If the y term goes away here because I plug a 0 in for y, I have 5x equals negative 5. So we divide both sides by 5. And we get x equals negative 1. For the y-intercept, I'm plugging 0 in for x. So I have 10y equals negative 5. Divide both sides by 10. Careful here, I get y equals negative 1/2. So when I draw my graph, this time I'm going to really space out my numbers so that I can get the 1/2 in there. But x, I want to go in the negative direction, so I want negative 1. And for the y, I need negative 1/2. So if that's 1 and 2, there's negative 1/2. And again, connect the dots and draw your line. Here's an example that's a little more complicated, but what we need to make sure we do first is get all of our x's and y's on the same side. So we don't want x's on the left and the right and y's on the left and the right. That just makes things a little more confusing. So let's clean it up in the beginning. So if I add 2x to the other side, I'm also going to subtract 2y to the other side. I'm going to do it at the same step. So we're going to add 2x to the 5x. We're going to subtract 2y from the 4y. And let's see what we get left over. Those are both going to cancel. Negative 5x plus 2x is a negative 3x. 4y minus 2y is a positive 2y, and it equals negative 6. So you can see cleaning up the equation then is going to make it a little bit easier to solve. X-intercept, the y term is going to disappear because I'm plugging y in for, or 0 in for y. So we get negative 3x equals negative 6. Divide both sides by negative 3, and we get x equals 2. For a y-intercept, plugging in 0 for x, that term disappears, so we have 2y equals negative 6, divide by 2, and y equals negative 3. Now when we graph, we are going to positive 2 in the x direction, negative 3 in the y direction. For our intercepts, whoops, I missed. We connect the dots and draw the arrows. Here's one where we have a fraction, and it's your choice how you want to deal with this. You can try to clear the fraction out. You can leave the fraction in and try to solve the problem. in this case, I'm probably going to leave the fraction in. This form of an equation, how it's written here, all the other examples, we've put them in standard form. Remember what standard form was from the previous lesson, that ax plus by equals c, where or x and y are on the same side. Here we have slope-intercept form of an equation, y equals mx plus b. Some of you maybe have heard that before when you're working with lines. So still the same concept here. To find the x-intercept, I want to put 0 in for y. So I'm going to have 0 equals 1/3 x minus 2. But I need to solve for x, so we're going to add 2 to the other side. So we get 2 equals 1/3 x. And then the question is, I got to get rid of that fraction. It's being multiplied by a third, so I need to divide by a third. Remember, dividing by a fraction is the same as multiplying by the reciprocal, so essentially, instead of dividing by a third, I'm multiplying by 3, which hopefully you can also see would get rid of the fraction itself. So I'm going to multiply both sides by 3. So I get 6 equals, those 3's cancel, 6 equals x. So my x-intercept is 6. For the y-intercept, it's a little bit easier in this form. This is actually slope-intercept form, and we'll learn that this number here in front of the x is your slope. We'll later learn that this number here is the actual y-intercept, and I'll show you why it works so easily. So if I plug a 0 in for x, this term is going to disappear. This 1/3 x, it's going away. So what am I left with? I'm just left with y equals -2. In order to find the y-intercept, I have to solve for y. This is already solved for y, so my y-intercept is -2. So I'm going to go to +6 on the x-axis, down to -2 on the y-axis, and connect the dots. Make that one a little bigger. So just because the equation isn't written in standard form doesn't mean you still can't find the x and y intercepts. You do have the option to rewrite that equation into standard form and then try to do it. You could get rid of the fraction first and then solve, or do it the way I did it, just leave the fraction there. In class, we will work on worksheet 5.2.